Now we're going to talk about power functions and index laws. A power function takes the form of y equals ax to the b. So here is my independent variable, which is x. My dependent variable is y, and a and b are constants. That's a power function. Some terminology. This is the coefficient. And this is my base. And this is my power, or another word is an index. So y equals ax to b is the general form of all power functions. We need to be very proficient at working with powers or indexes, so we'll quickly revise the index laws. The first one is a to the n times a to the m. When you're multiplying like bases, we add the powers or add the indexes, so it's a to the n plus m. Second one is a to the n divided by a to the m, sometimes written as a to the n over a to the m. Don't forget the vinculum there is a division, is equal to, if we add when we multiply, when we divide we subtract the powers. Number 3, when you raise a power to another power, so an or raise the power of p, is equal to, we multiply the indexes. Now we don't normally write the multiplication, we just say np, a to the n times p, a to the np. Number 4, anything raised the power of 0 is equal to 1. If you recall that if you had a to the n over a to the n, now from your knowledge of fractions, anything divided by itself is equal to 1. But when we use the laws of powers, we've got, when we're dividing, we subtract the powers, and we get a to the n minus n being 0. So a little proof, if you like, as to why a to the power of 0 is equal to 1. Number 5, we've got a to the p on q. When we have fractional indexes. Now that can be written as a to the p, or raise the power of 1 on q. If you multiply p times 1 on q, you get p over q. And when we've got a to the p to 1 on q, that will be, now 1 on q is the q3 of a to the p. It's equally likely, another way to express it, we could have split this up as a to the 1 on q all raised to the p. So that can be expressed as a to the 1 on q all raised to the power of p. Once again, when you multiply those two together, we're going to get a to the p on q. Now once again, that a to the 1 on q is the q thread of a, and that's all raised to the power of p. So two different ways of expressing a to the p on q. So you've got the q through of a all raised to the power of p, or you raise a to the power of p and then find the q through to the answer. So that's fractional indexes. What's the meaning of negative indexes? A to the minus n equals 1 over a to the n. So that one's good. if you've got xy in brackets all raised to the power of n, well, that'll be x to the n, y to the n. Okay, so don't get confused. If you've got a x to the power of n, this a, the coefficient, is not to the power of n. The power only applies to the base here, not to the coefficient. So that is not a to the n, x to the n. If you want to imply that, you need to put brackets around there, and then you'll get a to the n, x to the n. So when you've got brackets around that, everything inside the brackets has got to be raised to the power of n. And I think if you can remember those 7 rules, you'll get through all the questions and all the things you need to know about powers.